Hello, everyone, and welcome back to Getting Started with R Programming. In our last session, we got our R environment set up, learned how to set a working directory, and saved our work. So now that we know where to work, today we are diving into the core syntax of R, the fundamental grammar you need to start writing code. So, syntax are the basic rules that make the programming language work and help you understand how to write clean, error free, and functional code. We will be covering the three essential building blocks of R that you will be used in every single R script. These are variables, commits, and keywords. Let's start with the variables. When you are working with R for bioinformatics, data analysis, and machine learning, you are generally going to be working with data that is already stored in your computer. So, you are not going to be typing in too many raw values yourself. And how these data is generally stored in R, for that matter, is in the form of a variable. So, a variable is simply something that you give a name that stores some value. It could be anything, a number, text, or even a data set. And to assign a variable in R, you use this less than and hyphen operator that we called as assignment operator. Here you can see if I want to store the gene name TP53. First thing I need to create a variable name that is gene, then this assignment operator and the name of a gene that is TP53. Now, if I run this line of a code, nothing seems to happen in the console, but R has stored the value TP53 inside this variable gene in the environment section. So to retrieve this value in console, just type the variable name that is gene and hit Ctrl plus Enter. At this time, R prints TP53 back to the console. Or to see the output in the console, you can use print function, print within parentheses, mention the variable name that is gene and run this line of command. Again, we have the same output of this variable that is TP53. Let's look at another example. Say if I have a gene expression value of the 5 patient like this 2.3, 4.6, 3.6, 7.2, 4.5, and I want to store this value in a one variable. So to store these values in one variable, first I need to create a variable name. At this time, I will say that expression levels, then this assignment operator, and here to combine all these values, first I have to use this C function to combine the all values in this gene expression variable. Now, if I paste all these values in this parenthesis and run this line of a command, again in the environment section, we have a variable with name expression levels. So in this way, we can create a variable in R. Here is another example. Let's say I have this patient info data set in my working directory and I want to import this in R to work in it. First thing here, I need to assign a variable name. At this time, I will assign a variable name raw data. Then the assignment operator. Since this is a CSV file, so to import or read the CSV file in R, we have a command read.csv. Then I will select again command that is file.choose. This file.choose will help me to select any file from my local system. If I run this line of a command, a small window will pop up. So from this window, I will select this patient info file, and if I open it, R executed this line and a new variable raw data has been saved in this variable, that is raw data, what we have. So the variable raw data now have my patient info data in it. So in this way, by creating a variable, you can save any value. You can save a single value, you can save multiple, or even you can import your data sets. While creating a variable, there are some important rules that we have to follow. First, variable name must be start with big letter. As I did in these previous examples, I use letters to name the variables. But if I assign a variable that start with number like one gene, R throws an error. But if I create a variable with gene 1 name and assign the same value 25 and will run this line of command, so at this time a variable name gene 1 has been created. So variable name part start with number, but you can add number at the end. Even you can add the number in the mid of the variable name. Second thing is spaces are allowed in variable name. Like if I want to create a variable with sample ID, and if I say it S01 and run this line of a command, R throws a syntax error. That means R is consider this sample and ID as a different variables. Instead of a spaces, use underscore or dot. Like with same example, if I say sample underscore ID and S01, okay, if I run this line of a command, here sample underscore IG, a new variable has been created. Similarly, if I assign a variable sample dot ID at this time as 02 and create this variable, so both variable has been created. Next is another important thing. R is case sensitive. Like if I assign a variable that is glucose level with uppercase, have value 110. So this glucose level variable has been created. Again, if I try to create same variable name at this time, G with lowercase, glucose level, and I try to assign the same value that is 110. So at this time, both upper and lower case variables has been created. Even both looks similar, but are considered them as a different entities. So be vigilant about these things when you are working with your data set. If your column names are differ from these one upper and lower cases, it creates an error in your data analysis pipelines. Next thing is R overwrite variables without any warning. Like if I create a same glucose level variable, same name, but if I change the values, if I add multiple values, 110, 90, 120, and if I run this kind of a command, so at this time, here you can see previously it was 110, now it assign a new values to this glucose level variable. This is very important when you transforming your data. This point is also important when you're working with your data and when you are doing data processing step. Like I have this raw data column, I have this raw data. From this data, I don't need this patient ID column, so I want to delete it. To do so, if I do like this, let me do one thing. Data, raw data. Okay. So from raw data, if I want to remove this patient ID column by using this selector option dollar sign, I can choose the any column I want to select from my data. Then this assignment operator, and if I say null, so this line, if I run this line of a command, this code will remove patient ID column from raw data. Let's run this line of a command and check the output. Now, my patient ID column has been deleted from this raw data file. But what I did in this line, I create a copy of my raw data. If I check this data, so in this data file, in this data variable, I have patient ID column. This point is very important when you transforming your data. It is a best practice first to keep the copy of your original data and then start transforming it. Or you can do this, create a new variable for that data. At this time, I will delete the patient ID column from this data file, not with this raw data, but this data variable. To do so, I will select this data variable, then the square brackets, comma, -1. If I run this line of a command, but this code deleted the patient ID column, that is column 1 of my data, and it assigned a new variable, clean data. So in that way, in clean data, I don't have any patient ID column, but in this data, I have a patient ID column. That way, your original data remains unchanged and you can make transformation in another data. Next, we have commits. These are the little notes we add to our course. Commits are only for our own understanding. R doesn't consider it as a code. And commits start with these hashtag I use in my script. These all are the commits that start with these hashtags. So if you start writing your code with comment, R will totally ignore this. Let me change the variable name data to. If I create the variable name that start with this hashtag, the line start with hashtag, and if I run this line of a command, here you can see in the console and environment we don't have any output for data 2. Or if I remove this hashtag and write this data 2 variable with 23, so at this time R creates a variable named data 2. So you can add comments for your own understanding to explain what this code is doing. R will not consider it as a command. Here is a pro tip. You can turn your commits into a headings while working with the long script. Just add 4 hashtags before and after the comment. Let's say heading 1, again heading 2. RStudio has created 2 headings. You can navigate them to when you need it. Next important syntax is keywords. These are the reserved words in R that perform specific function. Like we have a list of these keywords like if, else, true, false, for, and so on. You can use help function to check what keywords exist in R. In these parentheses, write a word reserved and hit Control Enter. So in this section, you can find the description of the all these reserved words. This will bring up a list of all reserved keywords. So you can check the details of these keywords, how to use them with some coding examples. Similarly, you can also use this help function to learn more about other R functions like help, mean. So you can read out the detail of any function by using help or a question mark. Let's see how these keywords work. For example, I have this raw data, and in this age column, I want to sort out the ages of these participants. To do so, first I will create a variable sorted age. Then I will use the function that is sort function. Within that, I will specify my data, that is raw data. Selector column to select this age column. I want to sort out values from largest to smallest. So I will use the command decreasing equals to. Here I will use this true keyword, and if I run this line of a command, in this example, this decreasing is equals to true. That tells R to sort this age column from largest to smallest value. So if I check this sorted age variable, so the maximum age is 55 and the minimum is 26. If I check my actual raw data, values are assigned randomly. Now it's sorted from largest to smallest. Similarly, if I sort values, if I want to sort values from smallest to largest, so is at this time I will use this same function, but at this time decreasing will be false. Let me save into another variable, let's say age2, and if I check the output of this sorted age2, now at this time values arrange from smallest to a largest value. So in this way, these keywords help you to work with R. Now look at another keywords that are if and else, which we use for creating logical condition. How to create a logical condition? First, we will create a variable, let's say gene expression, and assign a single value that will be 30. Now, to check the logical condition, we use the if keyword. Then within these parentheses, we have to define our argument. Let's say I want to check if gene expression value is greater than 25. So I want the output with these curly brackets. I have to mention my output, what I want to print. That is, I want if gene expression value is greater than 25, the output that will be gene is highly expressed. If I run this line of a command, so here if is the keyword, it checks the condition if gene expression is greater than 25. Condition is true in this case, as we have gene expression value 30. Okay, so if in case if the condition is false, let's say here if we don't have 25, if I insert 50 and run this line of a command again, so here in console we don't have any output. But if we want any output, if the condition is false, we can add the else statement in this code. After this code, we will specify the else condition. Again here in the output, we want what? Print gene expression is low. If we run these if and else statements together, so at this time, we got the output gene expression is low. In this case, since gene expression is not greater than 50, the code inside the else block runs and R prints the gene expression is low. So as you can see, if and else and true or false are all keywords with a specific function. If you try to use if as a variable name, R will get confused and throw an error. Like if I want to create a variable with name if and assign a value, R throws an error. So you cannot use keywords as variable names. Next, we have another keyword that is for. For loop is used to repeat same task multiple times. Okay, I have this raw data. Raw data. If I check the structure of this raw data, so this is the structure of my data set that contain 20 observations, like 20 rows and 5 columns. These columns are age, gender, diagnosis, BMI, and smoker. So age is in integer form, that is a correct data type. It's a whole number, it's an integer, that's we are okay with it. But if you check the gender column is in character format, that is a string vector. But if you look at the data points, these are the males and female. So gender is what? A categorical. Gender is categorical data type. So in R, it should be in a factor format. We need to convert gender column from character to factor. Similarly, we have a diagnostic column. This is also a categorical variable. We have a two categories. The either person have a cancer or it will be a normal individual. So it is also a categorical variable. We need to convert it as well. The third column is BMI, that is in numeric format, that is our decimal parts. It's okay. It's in a correct format. We don't need to convert it. But for the smoker, again we have two categories, yes and no. So we have to convert this smoker column from character to factor. So in this data set, we have a three columns that we need to convert into a factor. First is gender with two categories, male and female. Diagnosis, again two categories, cancer versus normal. And smoker with two categories, yes and no. In R, if we want to convert the character to factor variable, we have a command s.factor. Here we can assign, at one time we can assign only one column. But in our case, we have a three columns that need to be converted. Instead of manually conversion, we will use this for loop function for automatic conversion of all these three columns with one line of a command. So how we can do this? First, create a copy of our raw data with name clean data. This will override this clean data. To do that, assign a variable clean data, but we want to save raw data as it is in this clean data variable. So my clean data and raw data now have the same values. If I check the structure of this clean data, so it is similar to this raw data structure. To convert columns automatically into factor, now create for loop function. To do so, we have a command keyword that is for. Here in this variable argument, you can assign anything. It could be I, X or Y or any name you want to give it. I want to give it a I. Then in vector, you have to assign the operation you want to perform. What I want to perform? I want to perform operation on my clean data columns. I want to convert them into a vector. So in this vector argument, I will pass n into column of what? My clean data. Now within these curly bracket, I have to mention the operation that I want to perform on the columns of this clean data. First, I want R to recognize if there is any character column in my clean data. This I indicates that it will check all the columns of this data. Next, what I want, clean data. So if there is any character column in my clean data, so in the next argument, it will be converted into a factor. If I run this line of command and check the structure of my clean data, so now you can see that previously it was in a character format. Now gender is converted into a male and female with 2 levels. That's okay. Diagnostic previously was a character. If I check the raw data, so you can see in clean data by using this loop function, we convert our gender column, diagnosis and smoker column into a factor. Previously, these all columns are in character format. So by using these keywords, we can transform our data and that's wrap up to introduction to R syntax. We have covered variable, comments and keyword. If some of these concepts, especially nested if else and loop function, doesn't make sense at this time, so don't worry. In our next session, we are going to dive into these topics in much detail. We will spend an entire lecture working with control structures like if else or for loops, so you will get plenty of hands-on practice.